So in part 3, let's tackle 2 more polynomial functions and try and find their zeros. These are a little bit more of a specialized cases, so they have little tricks and sneaky quirks to them. So example 5, our polynomial function this time is f of x equals x cubed minus 8. Now you'll notice this one is missing a bunch of terms. So remember when we did this in division, we'll need those placeholders. Same process though. So we know that there are 3 zeros that's coming from the degree. When we do our P over Q list, we'll end up with 1, 2, 4, and 8, all factors of P. Q this time is 1, so 1 doesn't impact that list. We then go graph it. What you're going to notice is that, again, from the graph, that it only crosses the x-axis one time, and that's over there at positive 2. So 2, it does something like that. What does that mean? Well, that means the other 2 zeros are i's, and we kind of expect that at this point. So we're going to come in and use 2 in our synthetic division process. So I have a 1, that's the x cubed. There is no x squared, there is no x, and then a minus 8. So we'll bring down our 1, multiplying gives me 2, adding is 2, multiplying is 4, adding is 4, multiplying is 8, adding is 0. So that was pretty quick and easy. I'm going to point out before I move on, that I really didn't need to do the graphing part of this. I actually already knew that the answer was 2 because the cubed root of 8 is 2, and that would have told me that the 2 is the correct number to use. So if we think about this, x to the third minus 8, 0. X to the third equals 8. Cube rooting both sides is going to give us a 2. The only drawback is this only gives me the real 0. It won't give me those complex, the I zeros. So we had to go through this process. Okay, well, what's left over here is an x squared because we depressed the equation, plus 2x plus 4. There are no factors of 4 that are going to add to 2, so we're heading to the quadratic formula again. Okay. So x is equal to the opposite of 2, plus or minus the square root of 2 squared, which is 4. Minus 4 times 1 times 4, all over 2 times 1. That's going to give us negative 2 plus or minus the square root of, well, that's 4 minus 16 on the inside, all over 2. That's going to give me a negative 12. Okay, because the negative will pull out an I, and 12 is 3 times 4, so that would be 2 root 3. So I end up with negative 2 plus or minus 2I square root 3 all over 2. Again, I'm recognizing that I've got an I for the negative, and 12 is 4 times 3, square root of 4 is the 2. The 3 is not a perfect square, so we'll leave it on the inside. We can cancel out all those 2's and end up with negative 1 plus or minus I square root of 3. Woohoo, yay! Okay, so where are we at? Well, we now know that the zeros of our polynomial function are the 2 that we found originally, and then we have negative 1 plus I root 3 and negative 1 minus I root 3. And the only reason to write these separately like this is because they're asking for the factored form. And when I write it in the factored form, it's a lot easier to pull the factors from them separated like this. So, okay, so f of x is going to be equal to x minus 2. That's this guy. And as I bring these over, I'm going to change their sign. So that would be x plus 1 minus I root 3. And again, notice how long this is. I ran out of room. And our other factor would be x plus 1. That's this negative 1 coming over as a plus 1. And we'll switch the sign on the I to I. Notice the conjugate pairing, the signs on the i's are opposite. The sign on the 1 is not, because the pairing only happens on the I part of that expression. There it is. So here are our zeros. Here is the factored form of that polynomial function. Moving forward into your next class, they really want to know that you just can solve these equations. So what they would ask you to do instead would be to solve x to the third minus 8 equal to 0. And if they want all solutions, then all the solutions are x equal to 2 and x equal to negative 1 plus or minus I root 3. So they wouldn't ask for the factored form if they're asking you to solve it. Okay, one more with a sneaky twist to it. And we'll be done with our section. This is example 6. Example 6 says, find the complex zeros of the polynomial function f of x is equal to x to the fourth plus 13x squared plus 36. There it is. Okay, so we'll walk through the process again. We know that we're looking for 4 zeros. We also know that P over Q is going to be all factors of 36. So 1, 2, 3, 4, 6, 9, 12, 18, and 36. And again, all I'm doing is I'm walking up, dividing it by each larger number, right, until I hit the middle, and then I start seeing the factor pairs: 4s and 9s, 3 and 12, 2 and 18, 1 and 36. And you're going to graph it. Okay, and from the graph, you're going to notice that it does not cross the x-axis. So it has no real zeros. So that means that all of the zeros we're going to find are going to involve an I. Now what? Well, we're going to flash back way back to chapter 1. When we did section 1.4, we used a substitution for equations that were quadratic in form. What you should notice right off the bat is that we have 3 terms, that the middle exponent is half of the first exponent. This is a quadratic function once we do the substitution. So we're going to use substitution. You might be able to factor it without it, but we'll use substitution. So we're going to let u equal x squared. So that's going to give me u to the fourth plus 13u plus 36. We're going to factor that. Again, what I'm really doing is negative 0. We're going to factor that. I said u squared. I hope I said u squared because we replaced the fourth with the square. Okay, we're looking for factors of 36 that are going to add to 13. That would be a 9 and a 4. So u plus 9 plus 4 is equal to 0. So u equals a negative 9 and u equals a negative 4. But we substituted. Remember we said u was x squared. So we're going to have x squared equals a negative 9. And we're going to have x squared is equal to a negative 4. And we'll come in and square root both sides. So that's going to give me x is equal to plus or minus 3i, and x is equal to plus or minus 2i. So 4, and they are all involving imaginary numbers. So our zeros for the polynomial function are 3i, negative 3i, 2i, and negative 2i. That means in factored form, our polynomial function would be x minus 3, x minus 3i, x plus 3i, x minus 2i, and x plus 2i. And if you were to multiply the conjugate pairs together, you'd end right back up with that x squared plus 9 and x squared plus 4, and multiplying them would give me the x to the fourth plus 13x squared plus 36. So don't forget factoring techniques that you already know, because they're going to come into play, and they do shorten the process anytime you can factor things. Okay, next we head back to section 5.3 and pick up the rational functions that we skipped over.